So I guess that you know CI/CD, but have you ever seen a CI/CD solution in the data landscape? After this movie, the answer is certainly yes, because I'm going to show you our solution how we integrate Snowflake with Git. Snowflake is a cloud database and Git is a version management system. Integrating the two will have a lot of advantages that I will show you in the next slide. Our solution is called Acheron Database Manager and my name is Paul Stapersma. So the business value that we try to bring to you is the following. We claim that anybody that uses our tool is able to develop 6 times faster compared to writing SQL manually and then copy-pasting it in order to deploy it on your Snowflake environment. 6 times is a lot, and this speed game, I'm happy to demonstrate this in the coming demonstration, how we try to achieve this. Next, our Snowflake changes are centrally managed in a Git repo. This allows to have full traceability of all the changes that are happening on your data landscape. Additionally, your data engineers will be able to deploy changes independently and fully automated. And last but not least, automatic testing, mandatory peer reviews, and the templates that we provide guarantee a high degree of code quality. So let's go and see how our solution works. So in your data landscape, changes come in. And every change, we apply 6 steps to them in order to make sure that a change integrates in the landscape and that the change will then be applied automatically. We do this in 6 steps, but the best way I find to explain these 6 steps is to explain them from right to left. Note that this is the reversed order to which the steps will be applied to the changes. So here we go. So first, what is a change? Well, in Snowflake, a change is a piece of SQL that needs to be applied to the test environment, to the acceptance environment, and to the production environment. We also call them the top street. When we apply this change, you should not tweak the change, otherwise the environments will be getting out of sync. Additionally, all changes are kept in Git, which functions as a single source of truth. Therefore, it makes sense to deploy changes automatically when they come into Git. When I give Git a change, Git will make sure it will be deployed automatically. And this is where the CD comes from, which stands for continuous deployment. Also, we want to verify whether a change fits on our landscape. That's why we have a dry run stage. In this stage, we apply the change to a dummy environment to see whether or not the change will be accepted. If it will be accepted, it means that the change fits on top of the other changes and that it can be applied to the other environments. In order to improve development speed, we created templates. Templates are reusable building blocks to set up your data environment. The only thing that you need to do is to configure them and then they will be converted into SQL changes and automatically applied by the CD steps. In the last step, we want to fail fast. We do a very quick check whether the change that is provided contains any errors, and if we find some, we fail directly so that the developer can make a fix. As a result of applying these 6 steps to every change that enters your data landscape, you will be guaranteed to have repeatable results on your different environments because there's no tweaking allowed with your changes. Also, there's proper version management in place that mirrors your landscape over time, and there's traceability, which enables auditability on your data landscape. So let's see these 6 steps in practice. So in front of you, you see my text editor. I'm using Microsoft SQL Code for this demonstration, which I can really recommend because it's a very nice editor to work in combination with the configurations that I'm going to show you. Let me first start by explaining the directory structure that you see on my left-hand side. First of all, there's a template directory. In this template directory, you can see a lot of various templates that you can use to set up your data environment. In order to use a template, you need to have configs. That's why there is also a config directory, the green one that you see here. And in this directory, there are various YAML files, like for example this one, that refer to a template and instantiate them with the following variables. Once a template is properly configured, our solution can transform it into SQL. And this SQL will be added to the repository in the output directory. So if I open this one, you will see that there are SQL files popping up here, which are automatically deployed into the Snowflake environment. I'm going to give you an easy example how easy it is to set up a new user using templates. So here we go. First, I'm going to look in the templates directory what template to use. In this case, I want to create a named user. Every template will have an explanation what variables should be set. Also, I can check in my directory if I already created a user, because in that case, I can just configure a new one. And that's what I'm going to do. I'm going up, I open my config directory, I will fold some of the directories that I already used, and here I see a create user. Here in named users.yaml, I see that the template I previously visited, which was this one, create named user.sql.g2, is being referenced, and there is one JSON object configured to create one user. I think it's also nice to show you already what this configuration will create as output. So for that, I'm going to copy the name, and every YAML configuration will be converted into an SQL file with the same name. So it's very handy in Visual Code that you can just search for named user. Here you will see the config, and below you will find in the output directory two SQL files. One is called vars.sql, the other is called plains.sql. I'm going for the plains.sql, and both are derived from this configuration. I will not explain in this video why there are two SQL files generated. That's maybe for a follow-up video. I'm going to the plains.sql, and here I can see that a user is created, and this is being done by the security admin. This user is called Snowflake demo user, exactly like the one that we configured here. There are some parameters that can be changed. If this template does not meet your company's requirement, it's always possible to change a template. You're in full control of that to make changes as you like. In this case, for the demo, I'm going to add a new user. I'm going to copy this block, paste it, and I'm just going to configure this second user with the way that I want to have a user created for myself. So my name is Paul. I like this to be my Snowflake username. User is created for a demo. And last but not least, my email address, paul@acheron.cloud. As you can see in the editor, there is a green bar here. This is the way that Visual Code shows you which lines you added. So when I go here to this icon, I'm actually going into a kind of Git overview where I can actually see the change that I created locally. So in named users.yaml, I can directly see what I did. I added these 5 lines. Next, I'm going to click on the plus symbol to stage my change. I'm going to give this change a name. And next, I'm going to push this change. Before I click on enter, I want to explain you what will happen. After I push this change, I will trigger an automated process that will first convert the template to SQL, and this SQL will be automatically deployed on the Snowflake environment. In order to see that this user didn't exist already in Snowflake, I'm going to a test environment that I created for this demo. I'm going to log in. I'm going to make my screen, browser full screen. I'm going to switch to an account admin, which is the highest role in Snowflake and allows me to see all the things that are happening in Snowflake. I'm heading to account and I'm going to check the users that I have. Currently, there are 4 users. Next, I'm going back to GitLab. And in this Git repo, we installed the Acheron database manager. You can already see some stages that have been applied. And I want to show you that after I push the changes that I just created, that an automated flow will be started. So I have my push message right here. I'm going to click on enter. And here we go. I'm going to do a manual refresh, but also if you would wait, you would see this thing popping up very quickly. First, we start off with a linting step. In the linting, it will be verified whether or not I created a mistake in my configuration for the template. It will, for example, check whether the template I'm referencing actually exists and whether the variables that I'm using are actually in the template to be configured. Next, the template step will be running. This step will generate SQL, and when successful, it creates a commit like this one. Then, again, a lint step, a template step will occur, but this template step will not create any new SQL because all the SQL that is generated is already there in the Git repo. So these 2 steps will always be green if these ones are green. And finally, when successful, and let's wait for that, it will be executed to Snowflake. Let's see what happens in the execute step. And the really cool thing here is that in the log you can actually see in green all the lines that have been executed successfully. The blue lines are command lines and are not executed by Snowflake. Looks good, right? So if you also like to see the commit that has been made after the generation step has been completed successfully, I can go back and click on this commit. And this is what I really love about generating SQL. You can directly see that a piece of SQL is added to an already existing SQL file. So let's check it out. We see now that there are 2 users created. One called Polstapersma, the one that we created initially, and the other one is the Snowflake demo user. The last thing that we need to check to be sure that, that I'm not talking any nonsense, is that Snowflake agrees with what we see in Git. Because that's the whole point, right? We want that Git shows us what's actually happening in our data landscape. So let's go to Snowflake. And here you see that my user has been added, it's enabled, and it's created at 6:17. And now it's 6:18. So validation complete. So coming back on the demo, what did we see? We made a configuration, and once we committed this configuration, we saw that our configuration was validated. Next, we saw that SQL was generated, and this SQL was added to the repository. We didn't see a dry run, because I didn't configure one. And then we saw a deployment step of the user to Snowflake, which we verified by checking in Snowflake whether this user existed. You can imagine that this simple demo also applies to other things in Snowflake, like roles or warehouses. And actually, we have templates for them as well, giving you the same speed with creating them as you would see with configuring a new user. So having these 6 steps in place, combined with a set of templates, will guarantee you to have repeatable results on different environments, to use version management as mirror of your landscape, because like you could see, all the SQL that is in our repo is also represented as actual objects in Snowflake. And last but not least, we have traceability in place, which allows for auditability. I hope that this demo made you very enthusiastic. And to come back to the business value of our proposition, using our approach allows you to develop up to 6 times faster. Your changes are deployed in a fully automated fashion. There is full traceability on your data landscape, so you can see when a change was deployed by whom. And last but not least, automatic testing, mandatory peer reviews, and templates guarantee a high degree of code quality. My name is Paul Stapersma. If you have any questions related to this video, feel free to contact me or contact Acheron.